All right, this worksheet is going to be motivation for the main topic we're looking at this week. So what I'd like you to do is if you can try problems 1 through 4 on your own before you get started, or before you watch the rest of the video, that would be for the best result. And then come back and watch it, and we'll kind of see what conclusions we get to. Hey, great, you're back. All right, so let's compute this first product. So we're taking this 2 by 2 matrix times this 2 by 1 matrix. So we should have the first entry will be 1 times 1 plus 2 times 1, so 1 plus 2. And the next entry will be 2 times 1 plus 1 times 1, so 2 plus 1. And so we'll get 3, 3 as a result. All right, so let's say we wanted to compute this product instead. So we want to take this matrix squared times this vector. So this is just going to be 1, 2, 2, 1 times 1, 2, 2, 1 times 1, 1. Now we can associate our multiplication however we want, and we actually already know this product. We know that this is 3, 3. So now we have 1, 2, 2, 1 times 3, 3. So when we go ahead and go to do that, what we'll get is 3 plus 6 and 6 plus 3, and so we'll end up with 9, 9. Okay. So now if we want to go ahead and compute it to the 4th power, what we're doing is we're taking 1, 2, 2, 1 squared times 1, 2, 2, 1 squared times 1, 1. Well, this we already know is going to be 9, 9. So we really have 1, 2, 2, 1 times 1, 2, 2, 1 times 9, 9. So let's do this multiplication first. So if we do that, still have the 1, 2, 2, 1. If we multiply this by 9, 9, we should get 9 plus 18, which is 27, and then 18 plus 9, which again is 27. And then for this last one, we'll have 27 plus 27 times 2, so 27 plus 54, which will be 81 and 81. So we end up with 81, 81. And so what you might have noticed is we have a little bit of a pattern here, right? What we're doing is we're taking this 1, 1, and whatever power we're raising the matrix to is what we're multiplying it by 3 to 2, whatever that power is. So this is the pattern that we've seen. So this is just the same as 3 to the 4th times 1, 1. And this is the same as 3 squared times 1, 1, and so on and so forth. Well, that's kind of cool. It's kind of nifty, right? That we can get multiples of this matrix multiplied by this vector by just raising some number to a power. That'd be really neat if we could do that all the time. Wouldn't it be nice if matrix multiplication behaved like scalar multiplication? Because we know pretty easily how to go ahead and multiply something by a scalar. Multiplying by a matrix, though, you might have looked at this if you were doing I'm going to try this before looking at the answers, and you might have seen like the matrix squared or the matrix to the 4th and went, oh, that's going to be really ugly. And then you might have multiplied the matrices together first, probably even in your calculator or Octave Online, and done things that way. But if we could just make it so that it's essentially multiplying by a scalar, that'd be very useful for us. That's much faster than trying to multiply by a matrix. So one of the fun little applications of this idea that's coming up is the idea of looking at heat diffusion states. So if we're looking at heat diffusion states, essentially these darker lines are where we're starting, or these darker lines are where we're ending up, and we're trying to look at the pattern of, if we're high, that's something where it's a higher heat, and if we're low, that's something that is a lower heat. And over time, we're getting towards these very dark lines in each of these 12 pictures. What I want you to do is I want you to talk about which of these graphs looks as though it'd be something that'd be easy to predict. So like some of these are very staticky and all over the place. Some of these seem a bit smoother. Some of them might be a little bit in between. I want you to talk about on the discussion boards this week what you think would be the easiest to kind of predict what happens next. So the idea is we're starting off with the lighter lines, and we're slowly over time becoming the more smoothed out curves that are the darker lines. So I want you to think about which of these would be kind of the easiest to predict what the next state would look like if we were going to draw the next line.